And all right, we are set. So what we'll go ahead and do today is, for those of you that maybe aren't familiar with Public Lab, Mimi is going to take an opportunity to show a little bit more about us. It's just a short 30-second clip to orient who Public Lab is, and I'll drop in the chat the text of that audio just in case you have a hard time hearing it, so you can read along.
Public Lab is an open community which develops affordable, accessible, open source environmental issues. We think citizens should be involved in framing questions, interpreting results, and drawing conclusions. Public Lab began during the Deepwater Horizon oil spill to address the information blackout which Gulf Coast residents faced. We used balloons to send cameras up 1,000 feet, taking detailed aerial photos of the spill. Today, our growing community is working on a new generation of tools to make citizen science better.
Thanks, y'all. So many of you might be familiar with that already, but just wanted to take a moment to let everybody know a little bit more about who we are at Public Lab. Oh, sorry.
Oh no, you can go ahead, Mimi. I was just dropping the text, like I said, for the video because they can't see it during share screen.
Ah, okay, awesome. So just wanted to let everybody know a little bit more about who we are at Public Lab. And now we'd love to learn a little bit more about who everyone on this call is. And I hope to connect with you guys online at publiclab.org afterwards as well. It's a great space for us to share our activities, share work that we're doing, share our environmental concerns, and connect with other folks who might be doing similar work or even just interested in the type of work that we're doing. So I'd love to invite folks to, maybe we'll do a little bit of popcorn if that's okay with everyone, to introduce themselves. What we're hoping to learn are your names, your name, your pronouns, where you're calling from, and perhaps something that you would like to take away from this call or learn or speak to. So I am going to popcorn over to Mike.
Mike Jabat, he, him. I'm a professor of science education at the State University of New York at Fredonia, about an hour south of Buffalo, right on Lake Erie, and very excited about hearing about the opportunities around solar balloons. So we've done some balloon mapping in the past, but ran into the same problem that lots of people have. I think we're really struggling to find helium and just the cost associated to it. So very excited to hear about new opportunities.
Awesome. And then Sasha, if you'd like to go ahead and introduce yourself.
Hi, everybody. My name is Sasha. My pronouns are she and her. I'm a geographer. I work at the University of London, kind of between themes of environmental justice, community activism, and contemporary art. I've been working around solar balloons for a number of years, like since about 2013, mainly around artists and activists using solar balloons to kind of do environmental sensing work in different ways. I also just published a little book about solar balloons and how artists and activists use them for different purposes. And I can also share personal PDFs of this book if anybody is interested. I'm also happy that my colleague Joaquin is here from the Aeroscene community. So nice to have you, Joaquin. Oh, sorry, and what I'd like to learn, I'd like to take away, I guess I'm just curious what people in the Public Lab network are interested in doing with solar balloons, and what are the kinds of questions that would be relevant to people in this community.
Awesome. And maybe that'd be a segue, Joaquin, if you'd like to go ahead and go next.
Okay, hello everyone. I'm Joaquin and I'm joining the call from Buenos Aires, Argentina. I've been collaborating with Aeroscene Foundation for the last 3.5 years approximately. And I think we'll talk a lot about solar balloons, but this is mainly what we do, and I have a lot of practical experience of flying solar balloons. I'm a cartographer. I've been very interested in the map knitter tool from Public Lab, which I studied extensively when I did my photogrammetry course at university. And I also have an interest in water. Specifically, I sometimes work, and I hope more, on board research vessels in hydrographic and oceanographic campaigns. So I'm super passionate about actually gathering data from nature by different means. Sorry if I didn't comply with all the specifications for the intros. But I think that's quite enough for the time being. Thanks for inviting me to be here. It's a pleasure.
Awesome. That was great. Thank you. You answered that. And Justin, if you'd like to go next.
There we go. Hi guys, my name is Justin. I'm an interdisciplinary designer. I work in ecological futures. So I'm really interested in human and non-human relationships. This is actually my first public lab event at all. So I listened to, I was in like a group conversation with Liz a while ago. And yeah, I just stumbled upon coming and checking it out. And I'm coming to you from Grenoble, France.
This is so exciting. We have so many people from all over the world today. Let's see, Ken, welcome. We're just doing introductions. If you'd like, you could just share your name, pronouns, and where you're calling from, and something you hope to take away today.
Hey everybody, this is Ken Eads, Baton Rouge, Louisiana. I'm a follower of Public Lab for a long time. Recently retired from the Department of Wildlife and Fisheries. I have interest in marine ecology and oceanography. And thank you for having me.
Awesome,
That's
thank
all.
you. And then it looks like I think we have Douglas left, if you'd like to go next. We might have a little bit of a delay on our end, so we can always circle back to Douglas. Alana, Jeanette, Stevie, if you'd like to take a moment to introduce yourselves, whoever would like to go first.
I'll go first in that order. Hi, everyone. My name is Alana. I am the KITS coordinator at Public Lab now. I'm calling from New Orleans, Louisiana, and I use she, her pronouns. I first came to Public Lab by way of doing environmental research through NASA Develop and using satellite imagery. Then I found out about a balloon mapping workshop that Stevie was hosting and have kind of been in the fold now, I think, for 5 or 6 years since that event. So yeah, I'm really interested in how the balloon makes the ability to capture remote sensing data and remotely sensed data accessible to people who can't actually, you know, collect it themselves with satellites, et cetera, and how the possibility of using solar balloons could make that even more accessible for folks that don't have, you know, the ability to buy and carry a tank of helium to their testing sites. So Stevie, I think popcorn to you.
Sure. Hi, my name is Stevie. Been with Public Lab for a number of years now, working on programs, but I initially spent a good bit of time with large red balloons in my hand and lots of different people around, mostly the US. And I'm interested in the shift away from the reliance on helium that I definitely have exercised in my mapping. Sorry, I hear I'm a little bit quiet. I might be having trouble with my speakers here or my mic, but I would love to pass it if there was Douglas or anyone else who popped in here that hasn't had a chance to intro, give you a chance to go off mute.
Hello, I'm Doug. I'm from Madison, Wisconsin. I've been a follower of Public Lab for quite some time now. I'm very interested in, I'm a cartographer and been mapping using kites and also drones. So I'm very interested in the solar balloon aspect because there are times when wind conditions don't, or I should say FAA permissions don't allow you to actually fly drones. In certain areas you can't. So I've used them in the past, kites for mapping Native American effigy sites and earthworks And so it's been real valuable and a lot of fun being able to show folks the aspects of these ancient earthworks from the air. So, so I look forward to hearing this on my first public labs video.
Awesome. And then Jeanette, did you have anything you want to add? Both of us are calling in from the Pacific Northwest, but Jeanette, if you had anything else to say.
Yeah, I'll just do a quick intro. Hi, I'm Jeanette, and I'm the research coordinator at Public Lab, and I'm brand new to balloon mapping in general, so just really looking forward to hearing about this particular approach and beginning to learn about the world of balloon mapping here. Thanks for having me.
Great. And so Mimi, it looks like you dropped some questions if you wanted to. It looks like that's everybody we're going to have joining for right now, but as people trickle in, I will let you all know.
Hi guys, so we're hoping to facilitate a really open discussion today. So if you have questions, if there's a pause in conversation, feel free to come off mute. You can also drop your questions in the chat so that we can queue things up from folks as well. I actually like to open the floor and invite folks who are currently using or have some current experience with solar balloons to tell us maybe a little bit about their work and perhaps about what you like about flying solar balloons. So I'm going to go ahead and open up that floor there if somebody wants to get us started. Sorry, I think it's Sasha and Joaquin who are actively solar balloon flyers at this point. I am a very novice, one time tried to get one up solar balloon flyer, but if you want that series of unfortunate events, we can share it.
Sure, I'll just start, and Joaquin, please jump in. Yeah, I've been flying solar balloons since 2013. I learned how to make balloons in the studio of Tomas Saraceno in Berlin, and Tomas, since the early 90s, has been making like solar lighter than air structures. And so a lot of my early experiences were about how do you fabricate a solar balloon structure using everyday materials. So using like reused plastic shopping bags, using PVC, using things that are easily available. I then taught solar balloon design and architecture for 2 years in a school outside of Berlin. And that was really, you know, we did like kind of all day, all night workshops with our students, kind of did like all night making sessions, like got up in the morning and would like launch these things at dawn. And that was the most beautiful moment for me, was always this kind of launching moment. So with solar balloons, there's a lot of kind of care that goes into the launch. And you're really kind of coaxing a very fragile object into the air and powered by the sun. So there's a lot of like kind of letting air into the structure, letting air kind of into the space inside, and then kind of waiting while the sun kind of slowly warms the balloon itself. And depending on the conditions, all kinds of things can happen. So you can have a beautiful launch where the balloon goes up like in half an hour. You can have launches where it takes like a couple hours or like even more, where it doesn't even work. Actually, the first launch I ever did with Tomas Saraceno, we drove like 4 hours into the countryside, and we could not launch anything because the weather was not good enough, right? So huge factor is weather, huge factor is air temperature, is sunlight, is dew and humidity, like all these different things have to be taken into account. So they're very temperamental objects. And I guess what I'm kind of doing more now is thinking about how solar balloons can be used as devices for air quality sensing. So we're developing with Joaquin and other collaborators an air quality measurement device that could be attached to these solar balloons that Aeroscene members make and create kind of vertical profiles of air toxin data, of course, without burning any fossil fuels or using gas along the way. So I'm working with Joaquin and an anthropologist called Deborah Swistun in Buenos Aires on a kind of air quality solar balloon hybrid project. But there's countless stories to tell about balloons, and I wonder if Joaquin wants to add a few words.
Sure thing. Okay. So yeah, where to begin from? Weather, I think, is quite important. But before getting in there, I thought that I could tell you a little bit more about Aeroscene, and I'll try to be super fast. Basically, we fly solar balloons with different purposes, but there is a huge sense of community. And I think that the experience of flying a solar balloon is something that will stay with you forever because it's quite special. And when I mean special, it's interesting to refer to the words people use when they contemplate one of Aeroscene solar balloons for the first time. They say something like, it looks like an amoeba, it looks like a spirit, it looks like a being from a Japanese animation movie. You know, we had all these comparisons, and it's quite magical. And the fact that it's flying just with the energy of the sun is pretty amazing. I pasted a couple of links about Aeroscene. I see that everyone, that Ashley and Sasha have done the same. And so the one recurring issue when flying solar balloons is the weather, like Sasha very well said. And to me, the primary aspect of meteorology for flying solar is wind. And I guess that for helium balloons, it's pretty similar. So wind is the enemy of flying a solar balloon. So you really want to choose a day with little wind, and actually above a certain speed. I'm going to refer to everything in metric system, sorry, but above 10 kilometers per hour of wind speed, we simply do not fly. As a security measure, it's quite a lot, 10 kilometers per hour for a solar balloon. And then the other thing that I think it's very like to the ground, you know, it's like, how do we do this? How do we fly Aerosolar? And Aeroscene and Tomás Saraceno, this artist that Sasha has also referred to, have many years of experience, and they have developed a balloon that is made of a very special fabric, which is super lightweight and super resistant. And the thing about the fabric that you use to make the balloon, it's all about the specific weight. And that means per square meter does this fabric weight, you know? But, and I think that maybe the most interesting thing for everyone here is how not to do this way, you know, how not to use this super like advanced fabric. And the answer is Museo Aerosolar, which is a project developed by Tomás Saraceno as well, which is about building a solar balloon with whatever is at your reach, which are plastic bags. So it's giving this plastic bags a new life in many sites around the world. I don't know about in the US or where you are, folks. What are the regulations on plastic bags? Some in my country, supermarkets no longer give you plastic bags. In some countries, like in the US, I know from the movies that you use paper bags to carry all the, you know, stuff from the supermarket. But if you can get a hold of lightweight plastic bags, this is super cool because it's super cheap and you're recycling, you're giving new life to this object. And basically, there are some instructions on how to make a tetrahedron, you know, which is this 4 faces object. But basically with thin plastic bags, and just wide tape, you know, like Scotch tape, you can stick plastic bags, and then the basic shape to form a tetrahedron by folding and sticking together is you need to start with a rectangle of proportions 3:1. So 3 width and 1 height. And then if you multiply this in the same scale to any size, you can build a balloon of actually any size. So for example, to be more precise, 3 meters by 9 meters, that would be like maybe a starting size, or 4 meters by 12 meters wide. And the bigger the balloon, the less critical the specific weight of the fabric that you're using becomes. So if you want to go big, it's cool because it's more probable that it's gonna fly well. And then just to not talk for a long time, I think that it's interesting to talk a little bit about security, you know, and regulations. And when flying a solar balloon, the biggest risk is that the solar balloon becomes detached and airborne, and you didn't plan for that. Because you can have a free-flying solar balloon if you apply for all the necessary permissions. And this has been done many, many times. It's kind of somewhat difficult technically because you need to be able to track this balloon. So airspace controlling institutions can know where the balloon is. So it's very important when flying a solar balloon that you make sure that it's correctly tied to the ground, you know, and this is super important. And at the same time, there are regulations even for flying kites and tether balloons in some countries. So I would suggest that you consult on the documentation to make sure that you're always on the legal side.
Awesome.
I think yeah, it's enough time for for my primer about solar balloons. But I don't know if anyone has any question or anyone wants to share experiences about flying. I know nothing about helium balloons. So.
Awesome. I was just going to actually ask that. It's just saying, Mimi and I both just dropped comparison guides. So Mimi had dropped one from a Public Lab earlier on contributor on solar balloons and like a helpful how-to guide that they had put together on our website, much to complement what Sasha and Joaquin were just sharing. And then the last one that I dropped was non-solar balloons, looking at kind of what Joaquin was saying, some helium ones that are publicly available on our website. But this is the chance, if before we jump into the next set of questions, if anybody would like to ask questions towards Sasha, Joaquin, Mimi, or I, feel free.
I guess my one question kind of for all of y'all is, what is like the average cost of a full solar balloon kit to carry, call it like a pound of weight?
So I was the question, like, what is the cost of a solar balloon full kit, like the ones that Aeroscene makes, or was it about like material costs?
I'm asking mostly the materials for the balloon, not the sensor itself, but just like presuming it would carry about a pound or maybe half a pound of weight.
Yeah, so again, that goes back to what Joaquin was talking about in terms of what kinds of materials one uses to make one of these things. So there have been humans, i.e. small children, lifted off Earth's surface with a balloon made of plastic bags. So clearly like good cost ratio there. The kind of human carrying solar balloons that Aeroscene creates, so we do make human carrying balloons. Those are much more expensive to do with their the kind of material that we're using, but also, as Joaquin mentioned, the kinds of safety measures and kind of safeguards that have to be in place, various tools and devices that need to be there in and on the balloon to make that happen. Joaquin, I think, will know more about like the specifics of what a typical Aeroscene Explorer, or sorry, no longer Aeroscene Explorer, Aeroscene Sculpture can fly. But again, I think maybe what's also good to remember is that it's not only the material we're talking about here in terms of how much weight can be lifted, but also Everything depends on the temperature differential between inside and outside the balloon. So your kind of lift equation is totally dependent on that difference in temperature. And if you have a greater difference, the greater the lift will be. And so we have some equations that we use in Aeroscene on calculating lift based on volume of air inside the balloon and based on that temperature difference and based on the kind of weight of the balloon itself. With Aeroscene sculptures that we fly across Europe quite frequently, we're not often carrying very large or heavy payloads. We try to keep it under 500 grams. Joaquin, correct me if I'm wrong. Is that right?
Yeah, I'd like to add a few things. But I mean, to give you a direct answer, Alana, I think that it's safe to say that it can actually cost almost zero. Because this is something you can make yourself, and it will work, and it will fly, and it can actually lift. I was making some calculations, converting pounds to kilograms, but it seems 1 pound is approximately half kilogram. So a solar balloon, depending on its size, can actually lift above 1 kilogram, you know? So, and the thing about building a solar balloon is that if you can get some friends and some people to give you a hand, it's gonna be cheaper. So in terms of materials, if you can get a hold of thin recycled plastic, you know, sheets or plastic bags, and just like white Scotch tape, this is totally inexpensive, you know, and some string that will resist these efforts. It can actually cost very, very little money. And I think that this is quite amazing, and you won't believe it until you make it and you fly it. But if you visit the Aeroscene site, you will see many occasions in which we built this Museo Aerosolar. And this is an amazing platform for taking whatever you want up in the atmosphere, and it can actually go as high as your tether cord is, you know. So once we had 2 tether cords attached, and one of our solar balloons got up to approximately 400 meters, which for us, it was quite a lot. Like many things happen up there in the atmosphere, you know, winds change, and it was a quiet atmosphere. And I like this word to remain, you know, in this meeting about quiet atmosphere, because this is exactly what you need for flying aerosolar balloons.
Yeah, and there are some commercially available solar balloons, but they're not as large, and they can't carry as much. So you'll see in the education sphere a lot these like 20-foot long by like, you know, 1.5-foot wide tubes that they sell to encourage students to kind of learn a little bit more about that. And they're common in like a physical science type of classroom. I've flown one of those with students before. They can't get quite as high as, you know, like your traditional helium balloon or kite, because they're really made out of cheap materials. But 50 of them are, you know, typically under $75. So they're quite expensive. And you could, if you needed to, you know, perhaps link a bunch of them together. I'm in New Orleans, so it's always hot and we rarely get wind. So we typically have really good balloon weather, especially in the summer. And I worked with a friend who had some students building solar balloons here in New Orleans, and then they compared to the flight of that long tube deal. And theirs were simply plastic bags that they ironed together. And then I actually have a question about this, because I'm not sure if it's a necessary step, but some of them painted the inside of the bags black. Some of them just shook a black pigment inside of the bag. And I'm wondering, does that, and all the balloons that I see when I look up solar balloons online tend to have that black color. Can you make a solar balloon any color, or does it need to be black in order to soak up enough sunlight and warmth to fly?
Well, I can give you a straight answer as well. They don't have to be black necessarily, no. And actually, if you paint a balloon, you're adding weight. So to me, it just doesn't sound like a good idea. And if you research a little bit about Museo Aerosolar, these balloons built of plastic bags, you will see that the plastic bags have different colors. And more surprisingly even, transparent plastic works perfectly. So it seems that the phenomenon of air heating inside of a contained volume, you know, of course, if it's black, maybe the lift force will be higher, but it doesn't need to be black. It can actually be transparent. Some of the most beautiful looking balloons have like different colors and transparent sections and black parts, you know, and painting the bags, to me, from my experience, it just sounds like you're adding weight.
Yeah, I guess I would just add really quickly that there, so throughout history, there have been some really amazing experiments in these kinds of things, Mimi, and I kind of talk a little bit about that in my book. And there was an amazing guy named Frederick Eshu from Iran who created a solar balloon in like the 1970s that was black on one side and had a kind of clear panel on the other. And he could rotate, he was kind of flying himself in the balloon. He could rotate the balloon, and depending on if the black surface was facing the sun, he would go a little bit higher. And if you turn the transparent surface, he would kind of go a bit lower. So there are these, I mean, throughout history, there's so much in the archive about balloons and the different kind of materials that are used and how people have different kinds of approaches to color and texture and weight. And it's a really rich history. And I think, yeah, we can look at some of these histories for inspiration as well.
Awesome. Did Justin or Douglas or anybody, would you have any questions, or Mike?
I could jump in with a question. I guess because I'm kind of new to the specifically like sensing with the solar balloons, I'm curious, maybe Sasha or Joaquin, like what are your, I'm curious to the diversity of use cases. I think I heard a couple comments on mapping come up. It sounded like Alana before was going to be like hinting at flying something. I'm just curious, like what are your go-tos? What's happening often? What can you tell me about what's common right now, and maybe a bit where you see that headed in the future?
Okay, I'll just start quickly, and Joaquin, please jump in. But so yeah, there are myriad use cases. I think one of the primary use cases I've been involved in is pedagogy. So thinking about how solar balloons invite us to feel the air and the atmosphere differently. So that whole process of like making a membrane that can fly with the sun is a very sensual and exploratory process that really kind of teaches a lot about energy and atmosphere and materials. So we've done a lot of kind of solar balloon pedagogies over the last 10 years. We've also in Aeroscene, again, done kind of environmental sensing work. So attaching different kinds of sensors to the sculptures and kind of flying them across Europe perhaps, and taking different kinds of data while those sculptures are flying. We've done things like make sound recordings from balloons while in flight, and have like very eerie and amazing recordings from Aeroscene sculptures at like 16 kilometers in altitude, like really, really weird, amazing sounds. We've done things like aerial mapping using a kind of the current version the Aeroscene sculpture float kit payload, which includes a Raspberry Pi with a small camera attached to it. And we have a kind of app you can get on your phone where during a tethered flight, you can link to that Raspberry Pi based camera and kind of see what the sculpture is seeing from where it is flying. We've done a lot of kind of awareness raising campaigns, so launching solar sculptures on particular kind of dates of activism. So on the 10-year anniversary of the Supreme Court ruling in Argentina that told companies to clean up their actions in a shanty town called Villa Inflamable in the south of Buenos Aires, there was a kind of environmental action campaign, and we launched some sculptures, and it was mainly Joaquin, not me. So Joaquin can say more about that. And then this last year in 2020, there was a human flight where a school teacher named Leticia Marquez free flew the DOAEC Aeroscene sculpture. So without any tethers or ropes tying her to the ground, free flew this sculpture to 273 meters above the desert of Jujuy in Argentina, carrying a message that was co-written by indigenous communities of that region against the mining of lithium on their lands. There have been many other examples, but Joaquin, I wonder if you want to jump in.
Yeah, sounds good. Amazing explanation, Sasha. Thank you. Yeah, I'm thinking about Aeroglyphs first. So a 3 years ago, I posted an image on Public Lab, and I'm pasting that for you guys. And basically, when I became involved in Aeroscene, I had an interest in data visualization, and I discovered what Aeroscene calls the Aeroglyphs, which are signatures in the air. So the idea for these drawings that are made with the trajectory of the solar balloon as it moves in the atmosphere, tethered, was to sign for different reasons. Maybe one reason could be signing again for a future free of fossil fuels. For instance, this has been part of Aeroscene's narrative. But then I began thinking about how else could we use these flight trajectories. So basically, a flight trajectory is easy to understand. It's like 3 variables, X, Y, and Z in space as the balloon moves. And then I began thinking, how can we add a 4th variable? And what could that 4th variable be? And we thought about like air pollution. Like, what if this drawing in the air could show the varying amounts of particulate matter, for instance? So this is why with a member of Aeroscene Argentina community, he programmed a little Python routine that can apply a 4th variable to these aeroglyphs, you know? So basically, we're building a sensing device in Buenos Aires, and this is my dream and objective with this device is from this data visualization point of view, is to be able to show, you know, some gases or pollution or whatever with these flight trajectories. And the other thing, which is quite amazing, which is every day, thousands of meteorological stations around the globe throw these helium balloons that are expendable to measure atmospheric conditions, you know, and they are using helium, they are using non-recycling material.
Using photogrammetry to actually 3D model the landscape. So we did the public lab balloon with this kit, and we were speaking of doing outreach to the Navajo Nation because the reservation is very close to, shares a border with Glen Canyon. But even with that, the cost of getting helium from this town in the middle of Arizona was exorbitant, and we couldn't rightfully go and present this to the tribe and say, here's a cost-effective means of you doing this research when it still is a $300, $400 per flight sort of thing in that area. Additionally, for like practical uses, and this is carrying a point and shoot camera. That's why I was asking for the half pound, because that's my usual metric for sensors with both drones and also balloons. My other means of using this kind of stuff with both balloons and drones is for coastal work. And so a lot of times it's like mapping sites that are out in the water, and they may be in one of 5 or 6 locations, and you can't really carry 5 or 6 tanks of helium on a boat. So basically all of the research that I'm doing with both drones and balloons are very much limited by the cost and also the practicality of the helium, which is why this is also interesting to me. I think that answered your question, Mimi, but excuse me if I'm wrong.
Ken or Mike, any insight into what y'all are flying?
So most of our flying is using kites right now, part of the Aaron project, one of the NASA SciAC programs. So we're flying cameras, sort of a very, very small Alana, very, very small camera that with programmed to record the images on the SD card. So lighter than a point and shoot. We're also flying a vertical profiler. So sort of almost like an anemometer that you would hold, handheld anemometer, but you can take it up with a fixture that's mounted to the Aaron fixture, the Aeropod. Just Aeropod is just a way to try to carry the payload up, but also to stabilize the payload a little bit so you don't get some of the other effects that are coming up. We have a drone, but even our campus, we can't fly our drone on campus because half of the campus falls into a flight path for the airport nearby. So it's a very limiting thing. And so we had flown a number of helium balloon flights prior to that, using the public lab materials. We took up, I modified our pole mapping camera that we had bought from Public Lab and took that up. But it's just, the cost is just, it's so unreliable to get helium. The cost is one thing, but we can't even if I was willing to pay, we really struggle to get access to helium. So it's
Why
a lot of my work.
that, Mike, if you don't mind explaining, why do you have difficulty accessing it?
Well, we don't have, it's probably similar to your situation on the Navajo Nation. We are so far removed from a place that delivers helium. So we were basically buying helium from shops that did helium balloons. So it was not a great situation. And so most of my work, outreach work, is with schools. So it needs to be a little more predictable than sort of planning and then hoping you can get the helium. So
I had heard that COVID was also impacting the availability of it. So I was wondering if that was part of it.
Yeah, we never got that. COVID is just limiting everything. So schools won't even let, we don't have access to kids even. We tried to do the get together on campus because it was sort of the center for a lot of the schools, but we were asked to not do that again. So I don't know. It was a beautiful day. We had a great time flying kites. But.
I have a question for Mike and Alana. I don't know if we still got time, but I'm super interested in how you stabilize the rigs, because as I understand, for, mapping, the more horizontal the platform is, the better. So you need less corrections when joining images. So maybe it's like a too big a thing to open up right now, but if you happen to have any link or any information on how you attach your cameras and how you get, you know, the most horizontal images, that would be amazing.
I've always used the Public Lab kit of making a sort of like makeshift gimbal using a water bottle to deflect the wind. We can send you the links to the build information because it's like the standard we promote when using balloon mapping, and it's just part of a water bottle cut in half.
And does that work okay most of the cases?
Worked out totally fine for me. All of my images, I rarely have any that like really tilt more than a few degrees, you know? Most of my issues come from like strings or things getting in the way of it, but that's my own user error.
Cool. And one more, sorry for so many questions. And do you exclusively use MapKnitter for joining the images, or is there any other tool that you use for creating the photogrammetry image?
Since the project that I was doing, I was needing the spatial data to go into GIS to be at a certain level of accuracy, which the Park Service was wanting me to get like sub-inch. They paid for a photo scan trial. And I personally have a trial for a Pix4D license. So whenever I'm trying to use like super, super high res, that's what I'll use. But if I'm just doing a map for visualization, I use MapKnitter.
Okay, sounds good. Amazing. Thank you.
So Joaquin, Amy posted a link to the Aeropod. That's how we're stabilizing our cameras. And we use MapKnitter, but we also use Open Drone Map for when we have to take it into a GIS project. So
I was actually about to mention Open Drone Map because I've experimented with it from images coming from a drone actually. And it's amazing. I mean, for zero cost, you get a very, very good quality result. So.
Awesome. Thank you for dropping those links in there, Mimi. And again, just as a reminder for everybody, all the links that were shared today, even when I lost connection, will be archived on our website. So you can always go back and reference those. We aim to get those up in the next 24 to 48 hours. But Stevie, did I see you raise your hand or?
Yeah, at good time. I just have one more question for people who have a lot of experience doing this. I'm interested in if you have any techniques for helping to direct your solar balloon over certain places. Yeah, it's one of the challenges that we have in using regular balloons, and there's a great symbiotic relationship you can have between a balloon and a kite that can help with that sometimes, but I feel like that would disturb your what you would need to get one of these off the ground. So I would love to hear any sort of tools or techniques you have for directing your balloon.
Joaquin, I think you're better at speaking about this.
Well, if I understood correctly, Stevie, because I'm not getting you like super loud, but I understood that you were asking like how to position the balloon like to where you want it to go. And in the field of solar ballooning, it really depends on wind, I would say, because, you know, wind will form a vector with the balloon and the rope. If there is a lot of wind, the balloon will go down, you know, so this is why we don't want wind. We want zero wind is the ideal condition. And in this quiet atmosphere condition of zero wind, you can actually place the balloon like straight up above you. So yeah, so basically it's all about, you know, and there's lots of planning when doing solar ballooning. I don't know if you guys do some weather planning. I like the Windy website and Windy app, although there are many of them. If you're flying in a flat zone, the NOAA's GFS weather model is really good. But if you're flying in somewhere with mountains, you know, there is this the European weather model, which is a little bit more accurate for this kind of geographies. and both are available through this windy site. So basically, I think it's all about weather planning, how much wind you got, and then just yeah, trying. And the other thing which is quite important about solar ballooning is that you're weather dependent, and part of flying solar is about adapting yourself to the rhythms of nature. So if you got deadlines, if you got like a tight schedule, you got, you know, some like commitments to achieve something in a certain amount of time, well, you better like kind of reformulate, you know, because yeah, it's totally weather dependent, but with today's available tools, you can pretty much accurately plan what's going to happen with the weather in the next 3, 5, up to 7 days, maybe.
Joaquin, I would just add about the Aeroscene float predictor, which might be a fun tool for some people to know about. So the Aeroscene float predictor, I'm putting it in the chat, is an app and a platform where you can put in your location and your desired destination on planet Earth, choose your altitude, and see where a purely solar and wind powered journey would take you. So it's actually using NOAA wind data as its base, and the app was created in collaboration with MIT's Earth, Atmospheric and Planetary Sciences Department. And it's really kind of about thinking about how does global aerosolar movement work and look like. And it's very playful and fun and great for students. For those of you who are teaching, I use this with my students every year.
Well, thank you, everybody. This has been such an informative conversation for me. Again, I'm new to flying, so I learned a lot from all of you. And thank you so much for the questions. I just wanted to welcome opportunities for you to follow us. We have our social media handles just dropped in the chat. We're on Instagram, Twitter, and Facebook. And we'll also have a YouTube channel where this recording will be posted later this week. And also, we have events at Public Lab that are like this, that are open to the community, that happen each week. The next one happens every week on Tuesdays, and it's called Open Call. So if you have questions that, you know, marinate after tonight and you want to bring them up to somebody, join us. And I think I just muted myself. Sorry about that, everybody. The open call starts 15 minutes before the top of the hour at 11:45 Pacific, 1:45 Central, and 2:45 p.m. Eastern. We do have a link on our website for other time zones. But again, that's a question for if you need help with getting set up on Public Lab to joining our community, or if you generally just have questions on a project you're working on. We do have open hour like this conversation that happens monthly, and that will happen in February. The date is still to be determined for February. We're looking at possibly a conversation around frac sand mining and other mining events, so stay tuned for that one. And Mimi, if you have any other last items, I'll let you go ahead and take the floor.
Yeah, just here in our last minute, I want to encourage everybody to come together online. We at Public Lab have a platform at publiclab.org that allows us to share our work, to ask questions of our community, and to discover what's going on in other places, not just in the US, but globally. So to connect on topic, to connect via geography on environmental issues. So I've dropped a link in the chat here just to our publiclab.org/welcome. But I encourage you to visit there, read up more information. And there's a solar balloons tag as well that you can subscribe to, so that as we kind of post more information or we start building more community around this, you can get those updates delivered directly to your inbox. And with that, I think we're just reaching the top of the hour. So I'm going to go ahead and stop our recording and pass things over to Ashley.